Hi everyone. Oh yeah. So we're going to talk about tonight about continuous delivery. So the title of the topic was "We Did It Our Way." Basically, it's all about our deployment portal throughout our continuous delivery pipeline we're going to talk about. But before talking about that, I wanted to talk about what we were facing 2 to 3 years ago. And this is what we had here on the left. Most of our developers were working on monolithic apps. All the Jenkins servers were very minimal. We only had 2 servers, serving something like 7,000 jobs to manage all the stacks we had. So every team has its own stack. Lots of repetition, lots of wasted resources. We also had one Puppet master with all the modules in one Git repository and one environment. I don't know if anyone could relate to that, but it was really, all right. So it was really hard to scale. We also had one cobbler with multiple Puppet classes, very hard to manage, not very structured. And the best we could do at the time was a 4-week release cycle for deploying artifacts to production. Now what we have today is more service-oriented applications where we have even more developers. We have more than 100 applications in development. All our Jenkins servers are in sync with each other, and we can spawn any server at any time. We have a scalable Puppet stack, 4 different environments from dev to production with dedicated module repositories, and one Foreman instance that helps us to organize Puppet roles per application, per service. And now we also have on-demand deployment to production for most of the teams. So how we did that? It's funny, tonight we talk a lot about unicorns. I don't know why, there's a unicorn here. And this is also the title of our project here. Why a unicorn? I don't really know. Probably it reflects the never-ending project of over-optimizing, considering requests from our developers, always improving our product or our offering, I would say. So here we got a typical workflow of a continuous delivery pipeline. At the top, you could see the continuous integration section where you have a user that commits his code to Git that broadcasts a signal to Jenkins. Jenkins built the artifacts which are stored, etc. And below we got the deployment section. So instead of using cascaded jobs as most of the Jenkins installation does, we decided to use promotions. So 2 sets of different promotions, one to deploy to environments and one to run integration tests and environments. So these promotions can be run by the user or cascaded, orchestrated, more or less by the users themselves through the code base. So we have like 2 different configuration files that every team can manage. On top of this, we are also offering dashboards to help them identify what's going on in their pipeline in real time. So this data are extracted directly from the Jenkins REST API through a PHP page that just takes as an argument the name of the job, basically. But here on the left, you can see the build history. So it's more the continuous integration part with all the build numbers, the different artifacts that are generated, the status of the build. Eventually, if there are some builds in the queue or builds in progress. And the different columns just show you the different environments where it's deployed and also where it's tested. So on the 3rd column here, you can see that there are a couple of builds that produce some errors, some tests errors, where the possible culprits are showing. We also offered more metrics and KPI. Here are different examples that are extracted from more complex information from Jenkins itself. This is an administration job that we run on a scheduled basis that extracts data from the jobs themselves. So we highlight the system reliability to see if there are errors in the system. The center diagram here is more to show the number of projects in development, in production. This is very recent figures actually, so we can see the progression in the center diagram. We have also diagrams about the repartition of our projects, and on the bottom right you also have a diagram that shows the different errors that's been identified during the different deployments. It actually helps us, to, for instance, to understand what our customers are facing in terms of errors. So how do we generate those pipelines is something a bit more interesting. So I talked about two configuration files. Here we have a build.yaml and a deploy.yaml, so it's YAML files as well. The build.yaml focuses on the continuous integration configuration, and the deploy.yaml on the deployment section to manage environments. I'm going to talk about those files in the next slide. From those configuration files are stored at the root of the repository on the master branch of every project. And this project also has the basic configuration file like build.gradle or build.sbt that allows us to identify the type of jobs that we are dealing with. All of this is actually processed by an administration job in Jenkins that uses a free marker template to generate the job configuration. Free marker template, well, the output of this free marker template, config.xml, is passed through the Jenkins REST API to generate the pipeline. We produce two types of jobs with that configuration, one master job and one dev job. The master job is a pipeline that we just shown earlier. The dev one corresponds more to the pre-flight builds if development teams have like feature branches or story branches, for instance, but they want to have a result from. So this build.yaml that I was talking about that describes the environment is very simple. It's just a text file that shows what Git branch we are dealing with, the JDK version, for instance, very basic things that constitutes the parameters from our continuous integration build. We also here specifies if we run unit tests, regression tests, coverage, and some notification information. So it's very basic. The deployment one is more interesting. It describes all the artifacts that we want to deploy, so their names, the type of artifacts, if you want to deploy to AWS. It could be to S3 for static content or some more complicated EBS packages. We describe also the Puppet modules and here the eradicated roles that are specific to the Unicorn project, actually, that Yann is going to talk to you in a moment. And the different environments, so from dev to production, as many environments as the users want. It's all VMs that are created at will for them. How do you orchestrate from one environment to another is also a part of this configuration. When from the YAML file, you can specify which one is the next stage, from dev to staging, for instance. At the moment, we do not really allow a straight deployment to production because we are not entirely confident in our automated tests. So we prefer that there is a manual validation. So we do not talk about continuous deployment, just about continuous delivery here. We also here describes the integration and system test targets, for instance. This is an example here of Jenkins page. You already all know about that probably. On the left-hand side, you have the build history, where you can see the different labels that represents the environments where the packages have been deployed. Every build under the date also specifies which package has been deployed to that environment. The list of artifacts, in addition to the usual artifacts, also lists the different log from the deployment. So these are real-time log. If you go straight there, and you have to refresh the page though. But if there is a Puppet deployment, you will see in real time what's happening on the machine. Talking about Puppet, we're going to talk a bit more about the modular structure and how we do to deploy in the infrastructure. So Yann.
Yes. So how we did. We structured our modules to be able to scale and to use it. So the first thing was, instead of having multiple roles per, multiple classes per host, we decided to move to a role-based configuration. So the idea is to delegate to the team the ability to create their own roles and to manage their roles and have commit everything they want. So to do this, we separated we have three different modules in Puppet. So using naming conventions, we were able to do this. So having the nap underscore role, we decide that it's a role managed by a team. Then we have the nap underscore something, which is the base classes we will apply to an host. So each time we provide a host, we deploy everything on this host and all the configuration. And we don't have any dependencies between all the modules. We try to use the common modules as much as possible. So those modules are the modules coming from the community, and we just download the modules from the community, integrate them inside our stash repository, and manage them like this. So, having name conventions, we created some tools to generate automatically some configuration and be able to pull everything from the stash repository and recreate an environment. So we use bash scripts and rerun to do this. And you can see an example of the kind of code we generate for the Puppet modules and the kind of things we get from the repo. So we have to manage 4 different environments, generally going from dev to staging to production, and means that each module needs to be able to go in one environment at one time. So how we did this was using some Git tag and not relying how sometimes we used to do, having some branches and having one branch for the development, one branch for the production, one branch for the staging. So we managed the tags using Git, and then we reference the tag for each environment in a file. And when we push this file to the production, to the repository, it will be pulled on all the Puppet masters and synchronize everybody using this. So you can see we have different, this is the configuration we have. So the different name, the different tags we put on the repository, and then how it's found inside our command and the file on the left. So we use also Foreman to assign one role to one server. So Foreman is used for server provisioning, physical or virtual or whatever. And we use also Foreman for having reports, so users are able to have a look at what's going on the machine, because they generally don't have access to, physically don't have access to the machine. So the Foreman check every 20 minutes, every 10 minutes, and get all the nap roles we have, and we are only allowed to assign one nap role to one server at a time. And user needs to define 2 different parameters which are required, which are the system env and the system roles. We use those two to generate configuration, and we use them to allow them to have some kind of, we are using Vigara data to get the parameters for the configuration of the modules, and so we allow them to have their own repository to manage this and not rely on us web ops to do this. So they have, that's how we generate the system groups and system role and system env, and we use this to read in Vigara data the different configuration files. And we also have one special group, one special parameter, which is system group. And we use this one for one specific reason, to be able to do some canary release, be able to deploy on one group of server, checking if everything is okay, and migrating to the other one. We also use PuppetDB to generate some configuration. So to store the configuration and to generate some configuration. We don't use at all any exported resources in Puppet. Was really slow when we tried this and not really scalable. So what we did is to directly create some query from PuppetDB from inside the Puppet. So you have some examples of how we did this, and there are some libraries existing in Puppet to do this. And we also use PuppetDB to query the active host on which we are going to push to deploy the service during the promotion. Previously, we were using M Collective, but the M Collective was quite slow and not really reliable on sometimes. And if we have some stale hosts with Puppet not running for ages, but still connected to M Collective, we don't really want to see this host appearing, and we would like to get rid of this one, and PuppetDB authorized this. So each artifact we generate during Jenkins build is pushed to one repository in Pulp. So we deploy all the application using RPMs, and generally we have one RPM repository for one service for one environment. And this is the generic configuration we have in our module, and where we define the base URL where we want to get the application, and then based on the system role and the environment, we are able to get the right repository. We also manage in our Pulp repository all the repo coming from external, all the external repositories. So we sync them quite regularly every day. And we have also our own repository for tools we manage ourselves, and we just push them in this repository. So everything works quite well, but we still have some new challenges going on. The first one is to improve the Puppet lifecycle. Today, it works quite well, but as you can see, we have different modules, and they can be in different environments. And sometimes we struggle with this because some developers are pushing their changes, but rely on modification, on new functionalities we provide inside Commons module or base module, and that are not available on production. So sometimes their build fail because they are using new versions that are not really pushed to production. So the idea is to refactor this and to automate, give more automated tests and be able to push this straight to production when having just one dev environment for us and only production, and having all the VMs aligned on the same version. We also need to train our users to use more and more Puppet and how to use the Jenkins pipeline, and we need to help them and be able to manage themselves. The last thing is we still have a lot of work to do to migrate the previous infrastructure to the new one, and it's still an ongoing thing and takes a longer time because we have a lot of modules and need to split them to smaller one and deploy them to production. So it will take some time, but we're on the way. And the three last things are all related. It's around the cloud and all these things. Today we use OpenStack internally, and for some services we deploy the application using AWS. But we don't use the same, we don't provide the same VMs for AWS and for OpenStack. So we need to align this and be able to have the same behavior and get all the metrics from the same place. Another idea is to use Docker to deploy the applications. Today, the idea is to be able to scale from internally to externally if we need to have more power. And the last thing is to be able to use and increase the security and provide new system for security. We still rely on old-fashioned security using physical firewalls, so we need to change this and be more flexible and work better with OpenStack and AWS. I think we've finished, so if you have any question, how many times do we have?
We've got time for a few minutes of questions. Whoever's fucking around with the TV, stop it. And yeah, we've got time for a couple of questions, so.
You can come to us afterwards anyway, if you have like more specific questions. Cool. Next slide.
And yeah, we're still hiring, so If you know any of these technologies, come and talk to us. Yeah, one question?
For previous speakers, yes?
Yeah.
Okay, previous speaker. Is Eric around?
Is Eric around? Okay. Thanks.
Thank you.